Okay, I would like to take the opportunity to share with you that there is actually a computational formula for the basic variance, you could say. So the defining formula of the variance looks like this, where we take each observation and subtract the mean, and then we square them and we add them together and we divide by n minus 1. So we have a focus on the variance. So this is what we have denoted as squared. Now, there is a formula that can be deduced from this, and which is used classically if you want to do hand calculations, or in pocket calculators actually use such a formula. And I will take you through the steps here. Basically, it just amounts to using the rules for, you could say, if the square of such a two-item thing. The square of this difference of two numbers is, by basic rule, the square of the first one plus the square of the second one minus twice the product of the two. Basically, that's using the basic formula for this. Then if we continue this step by step, let's go and sort of use the summation sign. I'll skip the I equal to n in the summation for the remainder now. We go the summation on this term, we use the summation on this term, and we use the summation on the last term. And actually, I take like the 2 and the x here, which does not depend on the I. Let me emphasize that on this one then. That I can take them outside the summation sign, basic calculus also. Now if I look at this, we see again, the first term does not change. Let me add this again. The second term, we are summing, let me add it again just to be explicit here. We are summing something which does not depend on the I. So we take it outside the summation, and then we are summing 1 plus 1 plus 1 plus 1, you could say. So altogether, it's n times whatever we are summing here, adding up here. And I maintain these two, and then I look at this number. I am summing all the x's. The sum of the x's is also, you could say, n times the average of the x's, actually. This is one way of putting it. By doing like this, we can actually see how here we have n x to the square, and actually here we can see we have 2n x bar to the square, I should say. So altogether, these two can be simplified. These two, this one is still the same. The first one is still the same. And then we simplify the last two, and altogether it's nx squared minus 2nx squared. So altogether it's minus 1nx bar squared, I should emphasize. It's x bar squared. Finally, to make it into the formula, which is can be found many places, we need to sort of rewrite this last part. We rewrite this by, let me just put the first part first. xi squared. We rewrite by saying, what is the average really? Well, the average really, if we spell it out, is the sum of xi divided by n, and all of this should be squared. And then the final result actually goes on the next slide. The final result then becomes, we have 1 over n minus 1 The first term just maintains the same throughout. And the second term, we just look up again. The n squared, sort of one of the n's here in the denominator cancels out with the n on the outside, and altogether we have minus sum of xi squared divided by n. And here we have, you could say, the classical hand calculation formula for the variance. The good thing about this formula, as opposed to the defining formula, which we see here, here's the defining formula, this is the definition. In the defining formula, whenever you get a new data point, you need to recalculate the average, and then you would have to start all over to do calculations if you were to do it by hand. This formula is what pocket calculators use, because you could just add in, actually in the last part here, the important part, I forgot the square here, like this. We basically have two sort of storages, one for the square and one for squaring the sum. And you just update these when data comes in. That's the pocket calculator principles, and that would be an easy hand calculation way of doing the variance. So when we use R in the computer, we don't have to worry too much, but this was just to show you what could be done if you're doing hand calculations. Thank you.